All right, section 4.6, we get into using congruent triangles. So in the past few sections, we've talked about how we can show two triangles are congruent. Today we're going to talk about how can you use congruent triangles to prove parts of triangles are congruent. So the main concept we're going to cover today is CP/CTC. And what this is it says corresponding parts of congruent triangles are congruent. Okay, so where the CP/CTC comes from, that comes from the first letter of the words in this statement. Corresponding parts of congruent triangles are congruent. So this just says that if the triangles are congruent, all of the corresponding parts are also congruent. Okay, so this brings us to the next part. It says, review from 4.2, if you knew that triangle ACB was congruent to triangle ECD, what could you conclude? So remember that order matters. Okay, so what matches up with A? A matches up with E. So what that means is angle A and angle E would have to be congruent. Okay, what matches up with C? C. So then these two angles here, we would call that, actually let's make this simple. Let's call this angle 1 and angle 2. So you'd say angle 1 is congruent to angle 2. And then B matches up with D. So angle B is congruent to angle D. So those are the corresponding angles. Now we gotta list the corresponding sides. So the sides, we gotta look at the order. So what matches up with segment AC? It'll be segment EC. So AC and EC will both get one tick mark, because those are the first two letters of the triangles. The next two letters are CB. So what corresponds to C and B? It'd be C and D. So CB corresponds to CD. And lastly, if these triangles are congruent, what corresponds to segment BA? BA corresponds to DE. BA corresponds to DE. So there are three corresponding sides and three corresponding angles. And if the triangles are congruent, then the corresponding angles and sides are also congruent. So what justifies these conclusions? Well, we were told the triangles were congruent, so we know the corresponding parts are congruent. This would be CP/CTC would be our reason. Okay, next, we have a proof to write. There's a few proofs in this section we're going to cover. Some of them are a little simpler, couple steps. Some of them are a little bit longer. Try to challenge you a little bit. So when we're doing proofs, remember the first step is always to put down the given. So step one would be segment AB is congruent to segment CB, and measure of angle ABD is equal to the measure of angle CBD. And that will be the given. So AB congruent to CB, and measure of angle ABD is equal to the measure of angle CBD. I marked that wrong. Let me fix that. So ABD and CBD are congruent. So we have one side and one angle are congruent. Okay, so as you look at this picture, is there anything that is not marked or given that we could mark? Okay, so we have one side, those blue marked sides, and then one angle, the red angle. There actually is a side they share. That green side is the same in both. That is BD. So we would say segment BD is congruent to segment BD, and the reason is reflexive property. Okay, so the reflexive property shows that that side is the same in both triangles. So now if you look, if I zoom in here, we have a pair of sides, a pair of angles, and another pair of sides in the two triangles. So what could you say about those two triangles? The SAS, or side angle side congruence. So we know those two triangles are congruent by side angle side. We have to make a statement. So if we want to match them up, if I say for the left triangle, let's call it A, B, D. How would you have to name the right triangle? What matches up with AB? If you look up here, AB matches up with CB. So the other triangle would be CBD. So A to B to D and C to B to D, the green and the yellow triangle. Okay, and I just saw this. This should say that AD is congruent. So make sure yours says congruent to. Mine had an @ symbol. It should say congruent to. So lastly, now we can say is segment AD is congruent to segment CD, and here's why. AD and CD are corresponding. You see how A comes first, D comes third, C comes first, and D comes third. So the reason is they're corresponding, so corresponding parts of congruent triangles are congruent. So we said the triangles were congruent, and then now we know that all the corresponding parts are congruent, so it'd be CPCTC. All right, so we'll slide down to the checkpoint. So again, it says to write a 2-column proof for each. So in the checkpoint, same thing. I do need to check this out. The proof statement, let's fix this. This should say, I'm just going to cross it right out. This should say angle M congruent to angle P. Okay, so the given. Always start with the given. Segment MR is congruent to segment PR. And segment MO is congruent to segment PO. And this is the given. Okay, so always start with the given. So let me mark that over here. MR congruent to PR and MO congruent to PO. So is there anything in this picture that you could mark congruent that isn't already marked? Or anything that you know is congruent in the two triangles isn't already marked? And if you think about the last one, when there's two triangles that are touching, they're sharing a side. So this side right here, RO is in both triangles. So what we're going to say is RO is equal to RO. And again, this is the reflexive property. Reflexive. Okay, so what we have here is we have a pair of sides, another pair of sides, and a third pair of sides. So we have two triangles that are now congruent because of side, side, side. So we would name the two triangles. The triangle on the left we can call triangle MRO. And the triangle on the right, if we match it up, MRO would match up with PRO. Okay, because MR has to match up with PR. That comes from right here. MR matches up with PR, MO matches up with PO. Okay, and the reason is side, side, side congruence. Now, since we know the triangles are congruent because of side, 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 do you notice that M and P match up? So we could say angle M is congruent to angle P, and the reason is corresponding parts of congruent triangles are congruent. So CP, CTC. So first part is put the given. Second part is prove the triangles are congruent. That comes right here. Step 3, side, side, side. The last part is look for CPCTC. Okay, if you need more time to write this down or just look over it, hit pause. I'm going to slide down to the next proof. We have 2 more proofs, and we'll do them both. So example 2 says write a 2-column proof. So step 1 is start with the given. So C is midpoint of segment AE. And that is given. We also know that AB is parallel to DE. So I'm going to mark that. AB parallel to DE. Okay, this one's a little trickier. So step 2, if we know that C is the midpoint of AE, what does that mean? What does the midpoint tell us? So if C is in the middle of A to E. Okay, C is the midpoint. It's in the middle of this red line. What does that mean? Well, it means it cuts in half. So if it cuts in half, we would say, all right, well, AC is equal to CE. And the reason is definition of midpoint. I'm going to abbreviate that. Definition of midpoint. DEF period of, and then midpoint. I'm going to abbreviate MDPT. Step 3. Is there anything else in this picture, in these 2 triangles that are congruent? Okay, I'm going to show you. These 2 angles, when you have a picture like this, they give you vertical angles. Angle 1 and 2 are vertical angles. So we're going to say angle 1 is congruent to angle 2, and the reason is vertical angles are congruent. So we know the vertical angles are congruent. So right now we have a side and an angle. Okay, this last part, before we show they're congruent, is kind of tricky. They told us these lines are parallel. So we have parallel lines. Okay, and then we have this transversal that comes through here. So if I draw that over here, parallel lines with a transversal. Do this. There. So what do you notice about these 2 angles? What would you call those angles? What special pair? Those would be alternate interior angles. So what we have is we have these 2, change colors to green. These 2 angles here that are alternate interior angles, and they're going to be congruent because the lines are parallel. This goes back to like chapter 3. Since the lines are parallel, we know the alternate interior angles are congruent. So step 4 would be angle A is congruent to angle E because parallel lines implies alternate interior angles are congruent. So that is another angle. So if you look up here, if we go around the triangle, we have angle, side, angle. So step 5 would be show the triangles are congruent. So we would say triangle ACB is congruent to triangle ECD. And this time the reason is angle, side, angle, congruence. And then lastly, this is 6 steps, so it's a long one. The last thing we would say is AB is congruent to ED because of CPCTC. Again, that's our whole proof. It was a long one, 6 steps, but we got to the end. Okay, if you need more time, hit pause. I'm going to quick do the last proof. So this one says write a 2-column proof given the picture. So step 1 is do the given. Angle B congruent to angle D, and C is the midpoint of BD. And this is given. So angle A congruent to angle E, and C is the midpoint. So if C is the midpoint of BD, so here's BD and C is the midpoint, we can say that, all right, well, BC must equal CD because of definition of midpoint. So BC equals CD. Okay. Step 3, in the same picture, we also have vertical angles. So I'm going to call this angle 1 and angle 2. So down here, I'm going to say angle 1 is congruent to angle 2. And my reason is vertical angles are congruent. Step 4, we have enough information to say the triangles are congruent. We would say triangle ACB is congruent to triangle ECD, and the reason is angle, angle, side. Okay, angle, angle, side, angle, angle, side. So last step would be step 5. Angle A corresponds to angle E. So we could say angle A is congruent to angle E, and the reason is CPCTC. Okay, and that's what we got for today, CPCTC, and we can prove corresponding parts are congruent.